Hey everyone, my name is Matt Keller, and I'm going to be talking to you today a little bit about software engineering. And software engineering is different than most of the other fields of engineering because it's only been around for maybe 50 or 60 years, whereas engineering like electrical or civil or mechanical have been around for 100, maybe even thousands of years. So they've had time to really develop all their processes and tools. And to give you an idea of how much software engineering has grown just in these 50 or 60 years, according to a World of Commodore brochure published in 1983, the Commodore 64, which came out a year previously, had 64 kilobytes of internal memory. Nowadays, you really can't buy any computer with less than 2 gigabytes of internal memory. That's 30,000 times as much information just in your single personal computer. So it really gives you an idea of how much this field has really grown in such a short time. So one of the biggest issues that's always come up is how do we create a process that we can follow again and again for any sort of software project that will allow us to create usable and good software in terms of all the best practices. So I'm going to talk a little bit about the waterfall model, which is really one of the oldest ones, some of its pros and cons, and then some of the alternatives to the waterfall model. And according to the textbook Essentials of Software Engineering by Frank Tsui, the waterfall model really is the classic software lifecycle model. So a lot of models and processes and all these things are really based off of this basic model that was created in, I think, the mid-60s. So the first step in the waterfall model is requirements. And this is really the phase where you decide, okay, what are we making? If you have a client who is asking you to make them something, they'll tell you, this is what I want it to look like, this is what I want it to do, this is how fast it needs to run, this is when it needs to be done by, this is how much money you have to do it. So that's when all of this gets set. After all of that is set in stone, then you go on to the design phase. And the design phase is where your software engineers and your software architects decide, okay, how are we going to actually build this program? What tools we're going to use? What software language are we going to use? Who's going to be working on what? What pieces fit together? So this is really, you haven't started coding yet at all. This is just still a setup phase, essentially. And every phase in this model you have to complete before you move on to the next one. So the next phase, once your design is all set, you move on to implementation. And this is the phase that most people associate with computer programmers and software engineers. This is where you actually sit down and code your program. So you follow the design, you make sure that you're following your requirements, and then you sit down and actually code. And a lot of people will think that this stage is the longest, or will spend the most of their time here, which can be dangerous sometimes because the next stage can be extremely long, which is the verification stage. And this is the stage where you actually test your program. A lot of times, the designers of the software program will, in their design phase, create a bunch of tests that their implementation will have to pass once they get to the verification stage. So that's where you run all these tests, you see what failed, what worked, and once again, make sure that you did all the requirements that you need to. And then you move to maintenance. And this is the phase where any bugs or any issues that popped up, this is where you fix them. So once you know what's wrong, then you go to maintenance. and you go and fix everything. You also are kind of in an infinite loop down here once your product is released, because this is the phase where when you get feedback on it, there's bugs, we want these new features. This is the phase where you do that. So this is really a good guideline, and one of its biggest pros is that it was one of the first guidelines. This was really a brand new thing when it came out, and it finally gave software engineers a process to follow, at least some guidelines to look at to make sure they're doing everything they need to. One of the biggest negatives about this model is that it is not flexible. So a lot of times you'll run into issues of you start implementing your program and you see, oh man, our design is not going to work. So you need to go back from your implementation up to your design phase. But this model does not allow for that. Or if you're verifying and all of a sudden you say, oh man, we didn't think of this, but this new thing should be a requirement. And this model really does not allow for that to happen. So that's one of its biggest negatives. One of the models that's really based off of this, but gives you a little bit more flexibility, is called the incremental model. And really what it is, it's just the waterfall model broken up into stages for different parts of the program. So the architects will sit down and say, okay, here's maybe 5 different pieces of this program that we can be working on at the same time, or we can do these other ones first and then do this one. And they will do this model for every single piece of that, or every unit that they've created to make up their entire program. They'll run it for all of them, and then they'll put all of them together and do it one more time to make sure that everything's working correctly. The other model that I'm going to be talking about is it's really new. I mean, at least in terms of engineering, it's new. It really started in maybe the early 2000s, and it's been adopted by a ton of startup companies, as well as some really big companies, called the Agile method. And it's hard to pinpoint exactly what it is because there's so many variations of it. So many people are using it and saying, this piece is good, but this other piece, we don't need that. So there's a lot of different variations of even the Agile method, but I'll show you one example that my senior design group is working on. So I'll show you that. So here is what's called Stories on Board, and this is a website that you can use for the Agile method. Really the concept of the Agile method breaks down to, let's break this whole huge project down into a bunch of really small tasks that we can just bang out quickly and keep moving. So for us, we're creating an app where it will show you a list view for nearby planes. So this is our overall goal, at least for this part of the project. Then you have these smaller ones called stories, and these are some of those kind of middle steps of what we need, such as let's say we need, so let's use launch app to store as an example. This really doesn't even have anything to do with coding, but this is still something that we need to do. So to launch the app to the store, we need to set up a test phone, which, as you can see, has been done. We need to get credentials from UNL, which we are in the process of doing, and then we need to actually submit it to the store. So while these aren't, just minute, tiny steps, they at least give us a breakdown of, okay, what do we need to do? And then we can check them off as we go so that we're not getting overwhelmed with how much work we need to put into it. So that was the waterfall model and a couple of different models that you can use instead, or variations. The waterfall model, while it has its issues, really was a huge, huge breakthrough in software engineering when it first got created. It's it gave a guideline to software engineers where there was no guideline. And while yes, there are issues, this is a constantly developing field. There's new models coming out all the time. There's new ideas, but really most of them all come back to this basic waterfall model. So if you know this, you at least know the general guidelines of software engineering. So thank you for listening, and I hope you all have a great day.